So, good day everyone. I'm Jeffrey Zimalbas from BSc 3P and I am here to report about materials and pavements. So, materials and pavements. So, unsay makam up sa imong una if makabasa ka or makadungog materials and pavements. So, for me, makam up sa akong una-una is highways, concreting, pavement, nga na, national roads, highways, nga na ang mukamap sa akong mind. So, without further ado, para atong maiwawaan ang iyang exact meaning and topic atong basahon, what is materials and pavements. So, it is a highway pavement or constructed of either asphalt or concrete and ultimately rest on native soil. The engineer must be familiar with the properties and structural characteristics of materials that will be used in constructing or rehabilitating roadway segment. The engineer must also be familiar with methods and theories for the design of heavy-duty asphaltic and concrete pavement, as well as various treatment strategies for low-volume roads. So, highway pavement kay gihimo siya or himuon siya either asphalt or concrete. So, for example, pananaho living here in Cagnaan, Matalom, Leyte. So, among bay is dool raman sa National Road. So, makita na ho, for example, is highway or the National Road nga maagi-agian bato bato to kuan Tacloban yan na. So, makita na ho nga it is built by concrete og ako po nakita padong sa Matalom na apoy asphalt highway pavement nga gihimo. So, the engineer must be familiar with the properties. So, dapat jud og engineer ka kaiba ka sa properties and types of materials para mo fit in nya masakto ang imong paggamit sa materials para ma-maximize nimo ang strength sa atong highway pavement. So next is the soil engineering for highway design. Highway engineers are interested in the basic engineering properties of soils because of soils are used extensively in highway construction. Soil properties are of significant importance when a highway is to carry high traffic volumes with a large percentage of trucks. They are also important when high embankments are to be constructed and when the soil is to be strengthened and used as intermediate support for the highway pavement. Thus, several transportation agencies have developed detailed procedures for investigating soil material used in highway construction. So, in highway design, soil plays a vital role before constructing a highway pavement. Nga naman kay soil, importante si mahibaw-an iyang properties kay sa soil there are many types of soil. Kung loamy soil, sandy soil, or bisag unsa nga type of soil because kani nga type of soil magvary ni siya kung unsaon paghimo or before going our project na siya significant or importance kay nga naman ato manguna-hunaon kung unsay mo labay ingani is if mahimo na atong highway, like for example pila ka loads or what type of vehicles moagi nga ni. So before ato jung i-sure nga hibota sa type of soil para atong magamitan og exact materials and exact volumes of materials og equipments gamiton para mahimo ang atong highway. Og also from the highway engineers nga kaibaw naman na kung unsaon pagdeal sa laing-laing type of soil. So soil characteristic, origin and formation of soils. Soil can be defined from the civil engineering point of view as the loose mass of mineral and organic materials that cover the solid crust of granitic and basaltic rocks of the earth. Soil is mainly formed by weathering and other geologic processes. They occur the surface on the solid rock or near the surface of the earth. Weathering is the result of physical and chemical action, mainly due to atmospheric factors that change structure composition of rocks. Withering occurs through physical or chemical means. So on and so forth. So withering kay may duha ka type, physical withering or chemical withering. O nganong na-appeal man ning withering sa atong topic because it is important to know the soil characteristic kay sa soil ibo siyang hibaw-on ug asa siya nagikan dili ingon nga ato jud i-specialize pero mas importante jud nga makahibaw ta kay soil kay magikan jud sa weathering kay for example chemical or physical. So also nagapon na siya role in determining soil characteristic. So soil may be described as residual or transported. So for example, transported magkuantag soil tungod for example baha gikan siya sa ibabaw sa bud, madaas siya sa padung ubos downhill. So it's a transported soil. So mabasa po nato diri nga residual soils are weathered in place and located directly above the original material. Unya transported soils are those have been moved by water when glaciers and so forth are located away from the parent materials. The geological history of any soil deposit has a significant effect on the engineering properties of soil. For example, sedimentary soils, which are formed by the action of water, and usually particles have settled from suspension in a lake, river, or ocean. These soils range from beach or river sands to marine clays. Soils that form by the action of winds are known alien soils and typically lost. Their voids are usually partially filled with water and submerged in water. The soil structure collapses. Soils may be described as organic when the particles are mainly composed of organic matter, or as inorganic when the particles are mainly composed of mineral materials. So, surface texture. The texture of soil can be described in terms of its appearance, which depends mainly on shapes, size, and soil particles, their distribution in the soil mass. For example, soil consisting mainly of silts and clays with very small particle sizes are known as fine textured soils, whereas soils consisting mainly of sands and gravel with much larger particles are known as coarse textured soils. The individual particles of fine textured soils are usually invisible to the naked eye, whereas those coarse textured soils are visible to the naked eye. So, it will be seen later in this chapter that the engineering properties of soil related to its texture. For example, the presence of water and fine textured soils results in significant reduction in strength, whereas this does not happen with coarse textured soils. Soils can therefore be divided into main categories based on their texture. So, miagi naman tani sa atong subject ni Ma'am Bakunawa nga natakol na nato ni ang coarse grain soils o fine grain soils. Nga ang coarse grain soils with is naajay sizes greater than 0.05 mm such as sands and gravels. So ang fine grain soils are those with particles less than 0.05 mm. So familiar na kadali nato ang surface texture. So in surface texture we have a formula of D. D is the maximum diameter of particles suspension at depth. Eta, which means coefficient of viscosity of the suspending medium. Gamma S, unit weight of soil particles, and gamma W, unit weight of water. So we have a formula of D, the square root of 18 theta over gamma S minus gamma W times gamma over T. So basic engineering properties of soils. Highway engineer must be familiar with those basic engineering properties of soils that influence their behavior when subjected to external loads. The determination of how a specific soil deposit will behave when subjected to an external loads is rather complicated because soil deposits may have heterogeneous properties. Highway engineer must always keep in mind that the behavior of any soil depends on the condition that soil at the time is being tested. Phase relation. A soil mass generally consists of solid particles of different minerals with spaces between them. The spaces can be filled with air and or water. Soils are therefore considered as phase systems that consist air, water, solids figure. So, schematically illustrates the three components of a soil mass of volume V. The volume of air, water, solids are VA, VW, and VS, respectively, and their weights are WA, W subscript W, WS, respectively. The volume VV is the total volume of the space occupied by air and water, generally referred to as a void. Porosity. So porosity, the relative amount of voids in soil is important quantity of those in some. So makita na to ang formula sa porosity and other components of soil para makuha nato inyong mass. So porosity, so the relative amount of voids in soil is an important quantity that influence some aspect of behavior. So makita to is N equals VV, volume of voids over volume sa pagkuha sa porosity. And pagkuha sa void ratio is E, volume of voids over volume of soil. So void ratio is the amount of voids, can also be measured in terms of void ratio, which is defined as the ratio of the volume of voids to the volume of the solids, and it's designated as E. So, mo yung void ratio. So makita na to sa illustration ang air, water, ug solid. So this sa left side is the W, which is the weight of all, weight total, and the volume total of the right part. So moisture content, the quantity of water in soil mass is expressed in terms of the moisture content, which is defined as the ratio of the weight of water, W subscript W, in the soil mass to the oven dried wage soils. WS expressed as percentage is a given as W equals WW over WS times 100 to get the moisture content. So next is the degree of saturation. The degree of saturation is the percentage of void especially occupied by water, as given as S equals VW over VV times 100. So dry density, to get out the density of soil, a very useful soil property for highway engineers to the density of the soil. The density is the ratio of the relates mass side of phase diagram and volumetric side. So pagkuha sa total density or bulk is the ratio of weight given sample of soil is volume, or gamma equals to W over V equals WS plus WW, weight of water, weight of soils, over VS plus VW, VA. Weight of air is negligible. So dry density is the density of the soil which water removed. It's given as gamma D equals to WS over V equals WS over the VS plus VW plus VA equals gamma over 1 plus W. So mga ni. So next is the Atterberg limits. Clay soil is with very low moisture content will be in the form of solids. As the water content increases, however, the solid soil gradually becomes plastic. That is, the soil easily can be molded into different shapes without breaking up. Continuous increase of the water content will eventually bring to the soil state where it can flow as a viscous liquid. The stiffness or consistency of the soil at any time therefore depends on the state which the soil is, which in turn depends amount of water present in the soil. The water content levels which the soil changes from one state to another are the Atterberg limits. So the shrinkage limit, first is Atterberg's, then second is shrinkage limit. So a shrinkage limit or SL, when a saturated soil is slowly dried, the volume shrinks but the soil continues to contain moisture. Continuous drying of soil, however, will lead to a moisture content which further drying will not result in additional shrinkage. The volume of the soil will stay constant and further drying will be accompanied by air entering the voids. The moisture content which occurs to the shrinkage limit or SL of the soil. So next is the plastic limit. The plastic limit or PL is defined as the moisture content at which soil crumbles when it's rolled down to a diameter of 1/8 of an inch. The moisture content is higher than PL. Soil can be rolled down to diameters less than 1/8 of an inch, and moisture content is lower than PL. Soil crumbles before can be rolled to 1/8 inch diameter. Liquid limit. So the liquid limit or LL is defined as the moisture content which soil will flow and close groove of 1/2 inch within it after the standard LL equipment has been dropped 25 times. The equipment used for LL determination is shown in figure 175. So, mao ni kana. So, kita na to, the formula of Li is, or liquidity index, is W minus plastic limit over plasticity index. So, liquidity index, Li, and W in natural moisture content of soil. So, permeability. The permeability of soil is the property that describes how water flows through the soil. It is usually given in terms the coefficient of permeability K, which is the constant proportionality of relationship. So, where U is the velocity of water in the soil, I is the hydraulic gradient, H over I is the head loss, H per unit length, K is the coefficient of permeability. So also shear strength, the shear strength of soil of particular importance to the highway engineer because soil masses will usually fail and shear under highway loads. The shear strength of soil depends on the cohesion and angle of internal friction. So standard specification for transportation materials and methods sampling and testing. So where S is shear strength, C is cohesion, and angle of internal fracture theta, and diameter, and a normal stress on shear plane. So the classification of soil for highway use. So mao ni atong basihan magclassified ng usa nga soil atong gamiton para sa highway. So soil classification is a method by which soil are systematically categorized according to their probable engineering characteristic. It therefore serves as means of identifying suitable sub-base materials and predicting the probable behavior of the soil when used as a subgrade material. See definition of subgrade and chapter 19. So, the classification of given soil is determined by conducting relative simple tests on disturbed samples of the soil. The results are correlated with field experience. Note, however, that although the engineering properties of a given soil is to be used in highway construction can be predicted reliably from its classification, this should not be regarded as substitute for detailed investigation of the soil properties. Classifying the soil should be considered as a means of obtaining a general idea of how the soil will behave if used as a subgrade or subbase material. So next is the Unified Soil Classification System or USCS. The original USCS system was developed during World War II for use in airfield construction. The system has been modified several times to obtain the current version, which also can be applied to the other types of construction such as dams and foundation. The fundamental premise used in USCS system that is the engineering properties of any coarse grained soil depend on particle size distribution, whereas those fine grained soil depends on its plasticity. Thus, the system classified coarse grained soils in the basis of grain size characteristic and fine grained soil according to the plasticity characteristic. So, in this table or illustration, the soil engineering for highway design UCS definition of particle sizes. So first rock is the soil fraction component. Second is the symbol and the size range. So coarse grain soils, gravel, fine, sand, coarse, medium fine, makita na to yung symbol G and S and its size range. So, for example, sa gravel, 75 mm to number 4 sieves, 4.75 mm. So on and so forth. So, sa fine grain soils, natay fine, silt, clay. For example, sa atong silt, have a symbol of M. Sa silt, a silt M. Clay is C. For example, sa silt is number specific grain size use Atterberg limits. Sa fine is less than number 200 sieve. So 0.075 mm. So napoy gradation symbols sa left, sa right is liquid limit symbols. So well graded is W, poorly graded is P. So, this is the unified classification systems. Ito i-zoom para maklaro.